Okay, I'm Manimaran. I'm from KSR College of Technology. Now I'm going to talking about the velocity analysis. In order to exert the proper design of mechanism, velocity analysis is a traditional movement. A designer is real interesting is variation of a quit-like link velocity for a specified inlet velocity. The interesting thing about a velocity analysis is you can determine velocities just by understanding two simple methods. First one is the first concept, a rigid body cannot elong or contract if any directions. That means if you take 2 points in rigid body, but velocity component parallel to the line connecting the point should be equal. If component velocity of point B is greater than A, then link will be start a length. In case is opposite, a link will be started in. Both these cases are equal and important since this is a rigid body. So the velocity component of both points is equal. That means if subtract velocity of A from velocity of B is velocity will have no component parallel to equal. It will greater than the equal. So relative velocity vector will be perpendicular to the connecting the body. In short, concept one can be similar as relative velocity between any 2 points. A rigid body should be perpendicular to the line connecting the bands. A second concept is applicable to mating surfaces. Mating pair of surface will never penetrate means this is the connect mating points or mating line for both the links. This line represents common link. The same point can have different velocity on different links. No penetrate means velocity component of both the link velocities along common normal should be equal. If velocity component of 2 is less than the velocity component of 1, the surface will penetrate. If opposite is the case, surface will detract. Both these cases are not possible to mating the equal. So velocity component along common normal should be equal. Since velocity component are equal, if we take a velocity difference of v1 and v2, since the mating surface cannot penetrate, should the relative velocity should have a more. Now we will apply this to concept of different mechanism to do velocity of analysis of thing. First one is four-bar linkages. It's one of the graphical method. We know input angular velocity, and we went to here. Approach is simple. We will say that bar or middle cannot expand this link. Since we know angular velocity of this link, we can easily find out the magnitude of the directions of velocity. But for point 2, we know that link here first concept we learned comes for help. Since this bar cannot elong or contract relative velocity between these points should be perpendicular to the link, which will lead to magnitude of velocity at point 2. From here, the velocity of link can easily be deduced. For example, omega 2 is equal to v2 divided by r2. And now consider the velocity, consider mechanism. We know the angular velocity of this cam. We went to find out the cam. This is the common normal at the time the mating. Consider the mating point which lies on both the cams. We know velocity, direction and magnitude of this point on first cams. But for second cam we know only the directions. Here second concept we learned comes to help. Since the links cannot penetrate, relative velocity should be perpendicular to normal. So we can find out magnitude of v2, which will lead to link angular velocity. Using same methodology, you can do velocity analysis of this any optimism. Omega square omega 2 is equal to v2 divided by v1. Hope you got a good introduction to velocity analysis. Thank you.